Hello, I'm Ed Armstrong, presenting on behalf of the PODAAC project on the NASA PODAAC report to the GRIST project. So the Physical Oceanography DAC is a 20 plus strong personnel project comprised of software developers and engineers, data scientists and engineers, and also physical scientists and applied scientists really working together to bring the PODAAC to where it is today. I thought I'd show you a little timeline of the PODAAC history, and we actually trace our lineage all the way back to the launch of CSAT in 1978. And there was the pilot ocean data system that was the foundation of the PODAAC starting in 1980, distributing the CSAT data. At that time it was on tapes. We see that the PODAAC in name started in 1991 as part of the EOS DIS project. And our first big mission that we supported was, of course, the Topix Poseidon launch in 1992. And over the years, you can see that we've distributed our data in various media formats, starting first with tapes and then with CD-ROMs and DVDs, and then eventually via the internet on disk via HTTP and FTP. And now, since 2020, we've been distributing data from the NASA Earth Data Cloud. And we're continuing to move all our data to the cloud, as you'll see. So going back to the era of pods, we actually have completed over 40 years of operation. We are distributing 100% from the cloud. This shows a timeline of the volume distribution since July of 2021 until now, and you can see a steady growth in the volume distributed from the NASA Earth Data Cloud. Again, that's located in Amazon, with a peak of 368 terabytes distributed a few months ago. So we've been engaged doing a lot of user engagement and community engagement vis-a-vis workshops and hackathons at various conferences and standalone workshops, mostly in support of missions like SWOT, the Surface Water Ocean Topography, and also S-Mode, smaller S-Mode and Opera missions. And so here we're holding hackathons and providing cloud access to the community in the workshop to work through workflows and develop workflows and really to learn how to use the data in the cloud. And recently, we're planning in 2023 to formally have a NASA Earth Data Cloud Hub where friends of NASA, so to speak, can come into the playground and develop and evolve their workflow. As well as we're planning in 2024 a SWOT hackathon. So a lot of these workshops I would say are tangential to the GRIST, but they do also provide opportunities and recipes developed from these workshops that are germane to using GRIST data in the cloud. So we've assembled all these tutorials and recipe in what we call the PODAAC cookbook. And so here you'll find like landing page for the recipes, code snippets, and actually pointers to the GitHub locations of where the code is stored and where it can be accessed. And we actually have a GRIST chapter in the PODAAC cookbook that has some recipes, and one of them is about how to access and use the Muir sea surface temperature data that's hosted in the Amazon Data Registry. And there on the lower right you see the link to where the GitHub link for the tutorials. So we have been probing in doing science, performing science enabling studies in AWS, and these are really exercises to develop cloud workflows to inform the user decisions on performance, access, services, and importantly, cost. The first one we did was to use the AWS Lambda service. This is an on-demand service, serverless compute service to do a Muir SST time series. So this might sound like a little trite exercise, but really what we're after in these coding exercises we're doing is to explore both the advantages and limitations of the wide variety of AWS services, in this case AWS Lambda. So on the right-hand side, you see the result of this exercise. This is just the annual global mean of Muir SST over 1 year for both the different resolutions. And we presented these findings at the last ESIP summer meeting. The other one exercise we're doing is exploring parallel computing using Dask on EC2. And here we're doing data downscaling of the Muir SST data from the 1 kilometer to 100 kilometer resolution. So again, this is a very kind of like a simplistic science use case, but what we're after here is benchmarking things like both speed and cost. So I'll be presenting more of results and talking more in detail of the results of these exercises in my presentation. So SST-specific progress in support of GRIST at the PODAAC. So we have curated and released 14 new GRIST data sets since the last meeting. So it's a wide variety of microwave and infrared data sets from both polar and orbiting and geostationary satellites. And we've also worked with the NOAA folks to resolve a problem with their MSG family of data sets that had a metadata issue, and we've resolved that for the forward stream. Our own dataset, the Muir Level 4 SST, has been updated and refactored to use 100% Level 2 SST cloud input data from sensors like MODIS and AMSR 2. This is one of PODAAC's most popular data sets, so it was critical that we continue to get it to run with the cloud input data. Muir is actually the default layer in the SOTO by Worldview. It's also used, it's a significant layer in the new emerging NASA Earth Information System. That's a visualization portal at NASA headquarters. We can delve in and actually see essentially the state of the Earth in real time. And PODAAC is the critical oceanographic SST layer in that infrastructure. So besides all the PODAAC data, all the tools and services are now 100% in the cloud too. So services like OpenDAP and HiTide and SOTO by Worldview, they all run 100% in the NASA Earth Data Cloud. Externally, we also co-chaired the GRIST sessions at the 2023 IGARS meeting, and we presented on the GRIST metadata catalog and search services in collaboration with Jean-Francois at IFRIMER, and developed a small tutorial on that as well. And we also presented on high-resolution SST fronts. We co-led the Intercomparison Technical Advisory Group. We were the outgoing chair of the GRIST Advisory Council, and we are also still co-lead of the CEOS SST Virtual Constellation, where we're supporting activities like the ARD Initiative, the Ocean Coordination Group, and the emerging CEOS Coast Virtual Constellation. So that wraps it up. Feel free to reach out and see our other presentations by myself and Suresh Venan, Wenhao Lee, Jorge Vasquez, to really see the broad spectrum of cloud-based tools and services and what we're doing with regards to cloud computing and science at this meeting. So we're really looking forward to engaging you at this meeting and learning more about what you're doing, and you can certainly ask questions about what we're doing as well. So for general inquiries, I just put the 2 links down there. Those are links for the user community to ask us questions directly to the PODAAC or engage us on the PODAAC forum. Thank you very much for your attention, and look forward to talking to you, many of you, later on in this meeting. Thank you.